video is going to cover using stoichiometry to find delta H. So in this problem, we have a balanced equation. We have the delta H for the reaction, and we see that 8.54 moles of CH4 are reacting. And we want to find the delta H when 8.54 moles of CH4 react. So we have the mole ratio here, which are the coefficients, and then we also have the kilojoules, the delta H. Those coefficients tell us how many moles react to make that delta H. So 1 mole CH4 is going to have 890 kilojoules of energy released, or 1 mole CH4 equals 890 kilojoules. But in this reaction, we don't have 1 mole CH4. We have 8.454 moles CH4, and we want to find delta H, so we have to do some stoichiometry. We're going to take 8.54 moles CH4, and we're going to set up conversion. We'll drag down mole CH4. Because we know the kilojoules per mole CH4, we can go straight to kilojoules. And then we plug in the numbers. We use that 1, that coefficient from CH4. And for every 1 mole CH4, we have negative 890 kilojoules. Top times top, divide by bottom. So 8.54 times negative 890 divided by 1 equals. And the answer that we get is negative 7,600.6 kilojoules. And I'm going to round that to negative 7,601 kilojoules. So that's how much energy is released when this much CH4 reacts. For this problem, we also have a balanced equation. We have delta H for the reaction. But this time we have 73.4 grams of Cl2 reacting. We're still going to use our mole ratios, our delta H. We're using Cl2. So we'll see that 1 mole Cl2 releases 822 kilojoules. But when we set up our stoichiometry this time, 73.4 grams Cl2, we drag down grams Cl2 and we realize we know how many moles make a certain number of kilojoules. So we have to go to that first. We can't go straight from grams to kilojoules. So we go to moles Cl2, drag down moles Cl2, then go to kilojoules. For this middle column, moles and grams, 1 mole, and then the grams comes from the periodic table. There are 2 Cl's, so you have to do Cl plus Cl. And you get 70.9 grams for every 1 mole of Cl2. Last column, we have kilojoules and moles. 1 mole, negative 822 kilojoules, and we got that from the balanced equation. Cancel units on the top and the bottom. In your calculator, you punch top times top times top, divide by bottom, divide by bottom. So 73.4 times 1 times negative 822 divided by 70.9 divided by 1 equals. And you get 850.98 kilojoules. And I'm going to round that. Oh, and that should be negative. I'm going to round that to negative 851 kilojoules.